All right, guys. How do we feel about How do we feel about what we learned yesterday? Pretty solid? Okay, real quickly, you probably did these for homework if you did your homework, but just real quickly to kind of review what we've done. All right, I'm looking at 22 and 23 real quickly, and I'm going to do even more than it asks. The question just said graph, but we're going to walk through real quickly everything we know. So right there, tell me what you know about this. Vertex is?
-2, 1.
Okay, so vertex is -2, 1. Come on. -2, 1. And I could go ahead and mark that right there. What is your length of your latus rectum?
18.
Positive 18 because it's a length, right? What is your length of your C value?
I got 4.
Fourth of that, which is 9/2 or 4.5. Now, by the way, let me clarify something. If you look in your book, there will be a formula for finding C, and it will say that C is a -4.5. So in most of my work, I talk about absolute value of C. I think I've been just saying C, but they have a value on C as a -4.5 because it based on the little formulas they use. I don't like the formulas because when I used to teach through those formulas, I didn't get a lot of success or as much success as I have teaching through the latus rectum. Okay, so because of the nature of me taking the absolute value of that, C, I always write C as a positive value, but if I really wanted to be accurate, I would say the absolute value of C is 4.5. And I think on my tests, I normally write absolute value of C. So it won't affect you because you'll be taking a fourth of that and getting a positive number anyway. But that's why I would probably put absolute value, is to be consistent in that regard. But I think of C as the distance from the vertex to the what? Focus, which is on the latus rectum. Okay, so other things that I could potentially ask that I don't need to graph is, what would be the equation of your axis of symmetry? Careful, it's not -2, it's x equal, because it's an equation of a line, right? X equal -2. And I guess if I asked you for the A value, what would the A value be? -1/18, right? -1/18. So that's the A, that's the HK, the vertex, latus rectum, yada, yada, yada. That's, at this point, I could ask you about focus as well, but I'm about to graph the focus. So if I'm graphing this, we start at the vertex and we do what? Oh, I could also say which direction is the graph opening? Down, because it's negative. And I could potentially ask you, what are the x-intercepts and the y-intercepts? And we've talked about how to do that as well, although I don't want to spend time on it today. So what would I do to sketch this parabola? I need a couple more points. Would I use the cheap trick? No, look how useless the cheap trick is. The cheap trick is take your A value, put it over 1, and treat it like a rise over run. So this is telling me to go down 1/18 and then over 1 each way. If I go down 1/18 and over 1, they almost look horizontal, don't they? And I'm not going to be able to know how really effectively to graph this. Is it going to be really wide? Is it going to be kind of wide? It's not helping me, which is why I don't use that method for really small A values, only for larger A values like you see in 23 and 24. So the latus rectum tells me to go down what? 4.5. 1, 2, 3, 4.5. That would be my focus. Okay? So if I ever asked you for the focus, how could I look at the vertex and write the focus? What would I do? Keep the x. And since I'm going down, I would subtract 4.5 from that 1, and that would give me what? I go 1 minus the 4.5. -3.5. And look, you can see I'm sitting there at -3.5, right? So -3.5. If I asked you that, you could do it. And then once I have that focus, which is right here, we know that what always goes through the focus? The latus rectum. So how do I mark that off? 9 each way. So 9 to the right will push me out here to positive 7. 9 to the left would push me out here to negative 11. But at the very minimum, I get my 2 points. That's all I really wanted was 2 extra points. And I sketch my my parabola as accurately as I can. I mean, try to avoid the V, okay, because that's an absolute value graph. Try to get a little curve on it, but I'm not going to grade. I'm just looking, did you get the points in the right spot? All right. And if I got this, a situation where the A value is not in between negative 1 and 1, but it's bigger, in this case, I'm going to use the cheap trick. But still, what can I do? What is my vertex? Negative 3, negative 1. And mark that. What is my length of my lattice rectum? What is it? 1/4. Not very helpful, but it is 1/4. What is my absolute value of my C value? 1/16. Not very helpful. And you can see if I was trying to use this information, I would have to, from the vertex, go up 1/16, which is almost nothing. And then I would have to go a total of 1/4, which would be what, 1/8 each way? How am I going to do that? Look, this is up 1/16. Here's over 1/8 each way. All right, sketch your parabola. Not very helpful. So even though I can find that information, it's not going to help me in graphing this, is it? But I can still find you the axis of symmetry. The axis would be what? Hello? X equal negative 3. I can tell you the A value is 4. I know the graph is opening up, but here's where I use my cheat trick. So I take my A value, I put it over 1, and I treat it like slope. So from here, I'm going to rise 1, 2, 3, 4 over 1, rise 4 over 1. And right there, I've got 2 extra points. It's going to give me a pretty steep looking parabola, but it's good enough for government work. Got with me? Yeah.
So what would you call it the lattice rectum? So this is not 1/4.
No, it is 1/4.
Why'd you cross it out?
Because it's not helpful. No. If I ask you for that, write that.
Okay.
But I'm just saying that's not going to help me graph this, is it? It doesn't make it any less true, but it's not just like right here. The cheap trick still works on this graph. It just doesn't work in a way that will help me sketch the graph. So both things work, but here the lattice rectum is really helpful in graphing a parabola. Here the cheap trick, which is A over 1, is real helpful. Oh, by the way, don't do this. Every now and then I'll have somebody go, oh, cheap trick is down 1 over 18. And they literally right here, they'll go down 1 over 18, down 1 over 18. No, the cheap trick is not that. The cheap trick is go up or down A, then over 1. Okay? Don't go up or down the numerator over the denominator. Don't think that way. In fact, hopefully that won't even cross your mind, because when you see a fraction like that, you'll be thinking, I want to use the lattice rectum instead. Are you with me? Okay, so we're going to review all this tomorrow and put it all together, which it's probably going to be a wasted day in terms of, I really don't think it's necessary, but I'm a little concerned about the people that are at home if they are having issues. So I'm trying to kind of work an extra day in there. So tomorrow I'll hand you basically an early review sheet, and you'll get a chance to really get all this stuff fluid in your head. So today, here's what I want to pick up with. This part 2. We're going to talk about today, how do we take a function in its function form, its f of x form, like this. Where am I? How do we take something in function form and turn it into something in parabolic form? Now, the first thing I want you to notice is this. What do the two of these have in common? They have one thing in common other than x's and y's. A. The A value on that is the same as the A value on that. That B and that C value, they're going to go away. They're going to turn into other things in this process. But the A is the same. Remember that for later especially. So what I'm going to do to go from here to here is I'm essentially going to complete the square. But it's a much easier version of completing the square. Because normally when you're completing the square, you have a 0 here, don't you? And you have to go through this whole process, get it all factored, square root both sides, move everything over there to get your final answer. Well, all we're going to do is get it completed and factor it, and we're done. So we don't have to go near as far as we normally would go with completing the square when we're transitioning from that to that. So I'm going to walk you through a couple problems. Most people don't have trouble with this, except for maybe careless hitters. So here are the steps I'm going to go through. And you're going to see it's very similar to what you've already learned. So what did we normally do when we were completing the square? There was normally a 0 there, but what were the first couple things we did? We moved the 7 over, and then once the 7 was over there, we did what? We factored out the a value. It's imperative that you factor out that a value first. Because if you try to complete the square and then factor out the a value afterwards, you don't get a perfect square trinomial. You might think you do, but you don't. So always move the 7, factor out whatever that a is. Now, the only difference is I've got what on the left? I don't have 0, I have a y. So look at that process real quick. So I've got the f of x, which I'm just going to turn into y because it looks a little better. I've got this f of x. I'm changing that to a y. You can see me do that right here. And I'm subtracting the 7 from both sides, which gets me to this. Now, I normally don't write that step. I usually, in one step, will subtract the 7 and then factor a 3 out, and I'll jump to that step. It just saves you a little bit of writing, okay? And it's not a big deal. Now, when I do that, you'll notice that I left a little space right here and a little space right here because I'm going to be completing the square. So in one step, you'll see me right here. I'll subtract that 7, factor out the 3, and I'll get to here. And then I've got to start the process now of completing this perfect square trinomial. So what were the 2 things I do to complete the square once there's a 1 right there with my x squared? I half the b value and square it. So half of the -4 is -2. And when you square it, it's going to become positive. So when you square that, you get a +4. Now, here's the biggest error I see on my test. People write +4 here, and then they write +4 here. Why didn't I do that? That's right. I added the number +4 in the parentheses. But if you think about the net result of this process, I really added +12. So even though I wrote +4, the net result to the right-hand side was a +12. I've got to put a +12 on the left. And then at this point, look, I'm done. -7 + 12 is +5. Remember the trick to factoring perfect square trinomials? What do? Square root the x squared, square root the 4, take the sign of the middle, and don't forget the square. And unlike normal completing the square, normally there'd be a 0 with that y, and I have to divide by 3, square root both sides, and move it over. I'm done. I've got my function now in parabolic form. And again, when you look at these 2 things, what are the only 2 things, are the only things they have in common other than x and y? Your a term remained unchanged. And that was the reason I'm pointing that out. Okay, so real quickly, here's another function. The only difference is it's got a negative. Let's walk through this process as quickly as we can. Change the f to a y. So changing f to a y right here. Subtract 11 from both sides right here. Factor out a -2 gives me what? +x squared, -10x. So here's my process in one step. How do I complete the square? Now that there's a 1 in front of my x squared, half the 10 is, it's -5, but whatever, it's going to end up being positive, right? Square that 5 and you get a +25. So I'm adding 25, but what was the net result of what I added? minus 50, so I put a minus 50 on the left side. Simplify it to negative 60, y minus 61. Factor your trinomial. And again, square root of the x squared, sine of the middle, square root of the 25, square it. And there is my function in parabolic fluid. So, real quickly on your own, tell me what to do on this example 3. We'll do this as quickly as we can. Example 3, what are you doing first? Change that to a y. Add the 35 to both sides, gives me y plus 35, leave a little space. And what? Factor out a negative 4, and so you have negative 4 times what? X squared plus 6x. Hey, for the next problem we're about to do, how did you get 6 from a negative 24? Tell me the math you did in your head, even though you didn't even think about it. You did what? You divided it by negative 4. Remember that on this next problem. If you ever are unsure how to factor something out of something, all I really did was take the negative 4 and divide it into the negative 24 and got a positive 6. I just put the negative 4 on the outside because that's the difference between division and factoring. Now, complete the square. What do I do? Add what to the parentheses? 9, because that's half of that squared. But what did I really add? Negative 36, so put a minus 36 over here. So on the left, y minus 1. On the right, negative 4 times what? X, sine of the middle, 3. Don't forget the square. And from here, I know I can find everything I need to find about a problem. But I got to get there first. This next one's a little bit trickier. So let's see if we can handle it. First couple steps. Change it to a y, subtract the 3, leave a little space. How do I factor out a negative 1/3? Now think about it. I know I'm going to have a negative 1/3 there because I got to pull that out. But how do I factor that? It's easy to factor it out of the first term. I just have x squared. How do I take out a negative 1/3 out of negative 4? If in that doubt, divide by the negative 1/3. So what's negative 4? Divided by a negative 1/3. It's the same as negative 4 times a negative 3. So positive 12. So positive 12x. Now, if you look at this and you're like, crap, I don't know if I'm right or wrong there. I'm kind of confused. Did I do it right? What could you always do to check? Couldn't I just distribute it back in and see if I get a negative 4 there? And sure enough, negative 1/3 times 12x is negative 4. So complete the square. What do I add? 36. If I add 36, what did I really do? I subtracted 12, right? Because a third of that is 12, is a negative 12, negative 1/3 of that. So I'm going to subtract a 12, and here we go. Y minus 15, negative 1/3, x plus 6 quantity squared. Now, there will come a point where the numbers that you have in your function are horrible. Like, what if this was your function? F of x equals negative 0.07 x squared minus 4,298x plus 1654. Do you want to complete the square on this process? I don't really. It's messy, it's nasty. Without a calculator, it's tedious. Now, I'm not going to say that that process I'm about to show you is less tedious, maybe, but it's very straightforward. Okay, it's a little bit of memorization that I've picked up on from calculus and also from algebra 2. I can't show you the calculus because you don't know how to take a derivative. Show you that maybe next year, but I can show you a trick to finding the vertex without completing the square. And if you really think about it, what are the only things I need to get something in this form? What are the only things I need? I need the vertex, which I have no idea what it is. So I definitely need the h and the k. And I need the a, which I already have if I can look at my original function. So I'm going to have that. I just need to know those two variables, the h and the k. Well, look at this. Look what happens. By the way, that's h, always. Negative b over 2a. So if you memorize that h is negative b over 2a, all I got to do to find my h is take the negative of the b value, negate the b, and divide it by twice the a value, and I will have the h coordinate of the vertex. And I have a question. If you know an x coordinate of a point, of any point, what do you do to find the y coordinate? Plug it back in your function?
Yeah.
That's true for any point, right? If you know x, you plug it back in to get y. Well, watch this. If I were to take a generic function without numbers with a, b, and c, this is kind of like what I did to prove the quadratic formula. And I were to go through the process of completing the square. Check it out. Change it to y, subtract the c, factor out an a, which is the same thing as dividing by an a. Take half of that. Now, this part's a little tricky. Half of a b over a is what? Half is b over 2a. And when you square it, you get that. So I'm going to add that there. But what did I really add? I added what, really? B squared over 4a. B squared over 4a. So if that's true, how does this factor? X. Square root of that would be 1b over 2a, sine of the middle. This is a mess on the left, but look at this right here and tell me, isn't your vertex of a generic problem like this, whatever I'm subtracting from x, isn't that negative b over 2a? Now, here's the part that's annoying. That's why I don't even know it. I mean, I have it written right here, but I don't know it. I've never bothered to memorize it. What am I subtracting from y? Technically, you would have to factor that negative out, and you would get this, right? I'm subtracting this. Well, I have yet to know a lot of people who memorize this part successfully. It's just a lot of ugly, right? But negative b over 2a, people have not had trouble with over the years. So here's what I do. If I can know that my vertex's x coordinate is that, can't I just plug that back into the function to find the y coordinate? And then not even worry about memorizing this over here? Like, think about it. If I know that, if I can find that, can't I just take that and plug it back in, whatever I get, back into my function to get the y value? Right? So with that in mind, this gives me a shortcut to finding the h value and then finding the k value by plugging that h value back in. And remember, we already know the a value. It's right here. So I have my hk, I have my a. I can shove it straight into my formula. Now, I'm not going to lie. Most of the time, I still like completing the square better. But there will come a time on this test, primarily with word problems, in parametric equations and pre-cal, in calculus, where the negative b over 2a thing is pretty helpful. So let's check it out and see how simple this is. Put this into that form using our trick. Now, what do I know already from this equation? What do I know? I know a is negative 4. So I already know my a value is negative 4. So let's find the vertex. So how do I find the h coordinate of the vertex? Negative b over 2a. So here we go. Negative b over twice a. 3 negatives, 2 of them cancel, and I get negative 24/8, which is negative 3. So I know my vertex has a negative 3 x coordinate. How do I find the y coordinate then? Plug the negative 3 back into the function to find the y coordinate. So how do I do that? Well, take my function. Negative 4 times negative 3 squared is negative 4 times 9. Negative 24 times negative 3 is positive 72. Minus a 35. And when you do the math on that, a negative 36 plus a 72 is a positive 36. minus the 35 is a 1, and that's my y coordinate of my vertex. And once I have that, x minus the -3 makes it positive, y minus the 1, put the a value in, and you are done. So let's try it. Number 6. We're trying to get to y minus k form. So what do I know right now? Y plus or minus something equals what? -2. I see the a value right there. Go ahead and put that in. X plus or minus something squared. I've already got the a in there. I just need my h and my k, my x and y coordinate of the vertex. So how do I find h? I am going to negate the b over twice the a. 2 negatives make a positive. 20 over 4 is 5. I've got my x coordinate of my vertex, which if you want, you can go ahead and plug in x minus that, x minus 5. How do I find the y coordinate? Plug the 5 back in. So f of 5, this is going to give me my k value, is -2 times what? 25 plus 20 times +5 minus a 27. So what is a -50 plus 100? +50 minus a 27, 23. So my y coordinate is 23. So y minus 23, and I am done. Now, if you look at that, you're like, that's a lot more writing than completing the square. I'd probably agree with you, which is why I normally would complete the square there. But this is another way to do it, which is especially nice if you have a calculator and the numbers are atrocious. All right, look at example 7. I'm going to get rid of all this. Okay, so right here, what do I immediately know? A is a -1/3. I can go ahead and plug that in there. How do I find my h coordinate? My h value, my x coordinate, my vertex. Negative the b over twice the a. Now that's 3 negatives, so I know I'm going to end up with a negative. So let me ignore the negatives for a second. I have a 4 divided by a 2/3. How do I take 4 and divide by 2/3? I multiply by 3/2. So that would give me what? 12/2, which is 6. So -6 is my h. And then how do I find my k? I plug the -6 back in. So -1/3, -6 back in there is a +36. -6 in there is a +24 plus 3, which gives me a what? -12, and a 24 is a 12, plus a 3 is a 15. So I got my h, I got my k, x plus 6, y minus 15. Not too bad. Okay, I got 3 questions I want to walk through with you that aren't necessarily directly related to these, but I just want to give you a little bit of extra thinking. And let's see what you can do. And I really have no idea why I didn't give you space to do these, but we're just going to do the best we can. Okay, so number 8, walk with me. See what you can do here. I'm giving you, on number 8, I'm going to put 8 right here, a point -3,5 and a vertex 2,7, and I'm asking you for parabolic form. So what do you immediately know you can do? I'm going to parabolic form. So y minus 7, because I have the vertex, equals, do I have the a value? Nope. A times x minus 2 quantity squared. So ignore all this 9 and 10 and all this stuff right here. I'm just working number 8 right here. Now, what do you think you could do to find the a value that goes with this particular parabola? Do what? What do you mean?
And the other ones,
Okay, I'm glad he said that actually. All right, so let me just say, I'm really glad he said it because a lot of people do this and you don't want to. It works sometimes, but not others. Now he said slope. Do you remember when I did the cheap trick? I did what? I took the A value and I went up over 1, or maybe down over 1, and I found 2 extra points, right? Is there a guarantee that this extra point is one of those 2 points, or could it be just another just random point out there? Might be just another random point out there. So if I look at this point and it's not exactly from the vertex up and over 1, if it's not like over 1 away, I couldn't use that. But if it was, I could. That would be a nice thing. But most of the time, it's not going to be. Okay? So that's one thing I don't want to do. Let me show you the second thing, though. Here's my vertex. Okay. I'm going to draw this again. Here's my vertex over 2. I'm going to show you something that a lot of people do incorrectly. And then they go, oh, there's another point. Left 3, 1, 2, 3, 4, 5. Right? So there's the vertex, and there's the point -3, 5. Now, I have people all the time, and they're thinking good initially. They go, oh, well, this must mean the graph's going down, right? True statement. They go, all right, the graph's probably doing this, which means if this thing is 1, 2, 3, 4, 5 away from the axis, then there's another point that's 1, 2, 3, 4, 5 away, which would make the lattice rectum what? 10. False statement. It sure seems like the lattice rectum, though, right? But what did we say the lattice rectum had to be going through? The focus. And how far is the focus from the vertex? C. And isn't C always what? 1/4 of that? So if this was the lattice rectum, if it was, then that would have to be my focus. But how far is that focus from the vertex? 2. Not 1/4 of 10, which is 2.5. So what does that mean? That's not the endpoint of a lattice rectum. But I have people all the time that will look at this and they think this and they go, oh, well, if the lattice rectum is 10, then my A value would have to be the reciprocal of that, right? Except that it's going down, they make it negative. If I do that and I plug -1/10 in there, I just missed this. I was close, but I've missed it. So tell me, what could I do to find A if all I do is have 1 extra point? Couldn't I use that for one of the many XY combinations that I have? I mean, there's an infinite number of points that would make this true if I get the right A value. That's one of them. But if I take that and I shove it in for X, and I shove the 5 in for Y, the only variable left is A. Doesn't it stand to reason I can find A that way? But don't make assumptions about the cheap trick or the lattice rectum from this other point. That is a huge mistake that I see on a problem like this on the test. So this would give me what? -5 squared is 25. Divide 25 into what? That -2. And I get A. And now I have my A value. So what is the equation of my answer in number 8? Y minus 7 equals -2/25 times X minus 2 squared. And by the way, -2/25 is pretty close to -1/10, right? It's like what? -1/12, 1/12.5. It's pretty close. -1/10 is -2/20. That's it. So you might get close thinking that's part of a lattice rectum, but there's no guarantee. I'm pretty sure I've taken those problems off the test where you would accidentally be right, so that won't happen. But it's pretty easy to plug in the other point. All right, what about number 9? So number 9. Again, sorry I didn't leave you over. Find the function in parabolic form which has these two x-intercepts and a max of 4. Is there anything about parabolic form, again, ignore this right here, that you currently know? Right here, is there anything you know? For what? The a value is definitely negative, right? Because if it has a max, you know it's going down. So you definitely know that the a value is going to be negative. Is there anything else you know? It's got to be y minus 4 because the max or the min is always the y coordinate of the vertex. So you also know that your vertex has a y coordinate of 4, which would give you y minus 4. So that you know. Now, what don't you know? You don't know the total vertex, do you? But stop for a second. I may not know the actual vertex this second, but think about the picture that you're given here. If I have x-intercepts at -2, and I also have one at +8, and I know that my max is up here somewhere at 4, right? What do I know about that vertex? Or the vertex's x value? I mean, are we drawing parabolas like this? No, they've got to have an axis of symmetry running through them, right? So what does that tell you? Where would the x coordinate be? Y at 3. Because 3 is the what of -2 and 8? The mean or the average. It's dead in the middle. So just take the -2 and 8, add them together and divide by 2, and you get 3, or eyeball it. Okay? So that means that must be my vertex. So actually, I know a little bit more than I thought. Now, I'm going to go back and ignore that negative for a second, but you are right, it is negative. I'm just going to put a back in there. Now, what am I missing? Just a, right? What can I do to find a? Plug one of the other points back in. Do I have any other points to plug in? I don't want to use the vertex. Look what happens if I plug the vertex in. What happens if I plug in what happens if I plug in 3, 4 in there? I get 0 equals 0, which is great that we verified that, but it's not helping me find a, right? So I need to plug what in there? Some other point, right? And I only have intercepts. So I plug in what? Either -2, 0, or 8, 0, whichever one you want. If I want to go, and notice it'll give you the same thing. Look, if I plug -2 in there and 0 in there, I get -5 squared. 25a is -4, so a is -4 25ths. But look what happens if I plug 8 in there. What do I still get? 5 squared is 25. Divide by the 25. I still get the same a value. Take that a value and plug it back in, and I'll have my equation once it goes back in. Not too bad? All questions that can show up on your test. Last one, number 10. Determine the max, the min, the domain, and the range. Now, we haven't talked specifically about domain and range, so let's, with this particular problem, let's talk about it. So number 10. And we're looking at these two questions right here. So number 10, we'll call this 10A. What is the max and what is the min of this example 10 first question? What's the max? Does it even have one? Does it? It's going down. So yes. So what is it? -4. So even though it's a negative, that's the y coordinate of the vertex, right? What's the min? There's no min. Good. I love that y'all are saying this right. Many people before you, when I say what's the max, people are writing the vertex down. Remember, what does max mean? The y value of something, right? So, and then, so there's your min. Now, what's the domain? If you missed this on a test, I want you to slap yourself. Okay? Domain. My parabolas on this test are functions. So they are going up or they're going down. Now, as a parabola opens up, it does get steeper, doesn't it? Does it ever go straight up? No, because if it did, it wouldn't pass the vertical line test, wouldn't be a function. So it is continuing to move what? Even though it's getting steeper, it's continuing to move outward. Is there any x value that is not covered in that domain? So your domain on this test of every parabola that opens up or down, which is all we're dealing with, is always all reals. Again, there's always one poor fool who misses this. Don't let that be you. Okay? Easiest question on the test, other than maybe the axis of symmetry, right? What is the domain? All reals. Now, the range you got to think a little bit about. What is the range? Now, range means what? That's right. From those x values, which y values show up? Now, this particular graph went down forever and up to the max, -4. So if I was writing that in interval notation, we always go least to greatest. What would I write for the range? From -infinity, all comma, up to -4. And do I include that -4 or not? Yeah, because it's a point, right? So bracket the -4. Now, if it didn't say interval notation, or if you just don't like interval notation, what could I say? What inequality could I write to show those values? Y, because it's range, right? So y is less than or equal to that -4. So either one of these is right, but should the problem say interval notation, make sure you write that. I don't know if I'm going to do that or not, but whatever. Either one of those is technically true. All right, what about this one? Max on this. Max. What is it? No max, right? Because it's going up. Goes up forever. It's unlimited. What's the min? 3. Y corner of the vertex, right? So this thing goes up forever, but comes down to a y value of +3. What is the domain? Do what? All reals, right? Do not be the person who misses that. What is the range? Now think about what's going on. I began at a y value of 3 and rose to infinity. So bracket 3, infinity parentheses, or what's another way of writing it? Y is greater than or equal to 3. Not too bad. All right, one last thing I want to talk about, which I don't know that I'm asking you even on the review tomorrow and even on the final review, but I might ask you on your test, so I want to mention it, is this. I'm just going to use one of the graphs here. You don't have to copy this down, but I want you to see something. What if I just gave you this picture? Whatever. Same thing over here. Is it 1, 2, 3? Okay, so what if I gave you this graph right there? And I said, what's the equation of this parabola? What's the easiest thing to notice? The vertex. So my vertex is at 4, 5. So I definitely know that it's at least y minus 5, a, x minus 4 quantity squared. Now, what can I do to find a? What have I been doing to find a? Plugging another point. Can you tell what that point is? Can you tell what that point is? This one? This one? Yes. So you're really looking for where the graph crosses through a crosshair. Now, I don't know for certain that it actually is at 8 up 4. It could be 8 up 3.95. I don't know. But that's my best guess, right? So now you might go down here and go, okay, it does cross at 8, 4. It also crosses at 0, 4. Those are on either side of the axis. So that would be consistent. But you know, if I look down here, it kind of also looks like it crosses at -6, 2. Now, it is possible that -6, 2 when I plug it in there and 0, 4 when I plug it in there. Let me think. -6, 2, and 2. It's possible that they would give me the same A value, but it's probably not probable. Okay, so if that happens, I would probably take, I mean, I would definitely take both A values. So if the A value that this spits out and the A value that this spits out are different, I would take them both. But you need to really look closely and find the actual point that looks like it is really crossing through the grid line as accurately as possible. If it's close, like right here, if you're like, oh man, well, that's pretty close, but you're like, it's not exactly, find a better one. But sometimes it's really hard to just make them cross just one pair. And in that case, I would allow different A values. So assuming that 0, 4 did work, if I plug a 0 there and a 4 there, I'm going to get 16, what, -1/16? Great. But if I plug the point, what do we say, -6, -2? If I plug a -6, -2 in there, I end up getting what, 100, -7 over 100. Those aren't the same thing, are they? But look at, if you did the math on it, they're probably pretty close. Actually, on this one, this might not be a very accurate parabola, but -1, -1/16 and -7. Yeah, one of them is -0.0625 and the other one is -0.07. So they are pretty close decimals, right? So in that case, I would have taken both of those fractions, but just make sure that you're thinking through how to find those A values and not making an assumption like this. People all the time, they go, oh, look, my lattice rectum is 8. So my A must be 1/8. How do I know that's not right? Because if the lattice rectum were 8, what would the C value have been? And is that lattice rectum 2 away from the vertex? No. So be really careful about making bad assumptions about that. All right.